Well, thank you very much, everybody. That was really great. I feel like I've learned a lot. So I'll ask a few questions just to get things started, but very quickly want to have your own questions. So my first question is the following. So I've seen applications of machine learning. They're all very exciting. As a PM, when should I think about using machine learning? When does it make sense? When does it not make sense? And also, there's this perception that companies like Google or Airbnb have so much data that they can do machine learning. Like, how much data do you really need?
Can you hear me? Yeah. Okay, cool. Yeah, so on the first question, when should you use machine learning? I think oftentimes it makes sense to start with a heuristic solution. So something that you can get out the door that works. And then once you have that completed, then you have a baseline that you can compare your model against, which makes the development process a lot easier. The other thing that you'll find with that is oftentimes it also provides you with the data that you need to actually train the model, because you'll be able to see how users interact with the product in production.
And I would add on to that in terms of like when should you use machine learning. Leonard kind of mentioned that before. If human experts can give you a set of rules to solve the problem, and that's enough, then you should definitely go with that and not go with, right, like just overall kind of look at, like getting data and like learning from that and that sort of thing. And also I echo, in terms of like if you're very early in the product lifecycle and you're just entering the market, you're a startup, right, and you're still trying to find product market fit, and if you don't have the right resources, like you don't have like 10 machine learning engineers to build models for you, I would say definitely start with manual approach, right? Like do start with something that doesn't scale, and doing that process, actually you will learn a lot of kind of intricacies about the problem as you're finding product market fit. So let's say at that point you don't need to jump into building a machine learning model yet.
Yeah, I'll agree and also add just a couple things and a few examples of that. So one, I think you should use machine learning when kind of the use case and problem you're trying to solve is something that you feel like you could even replicate as a human. So example of that is we were looking at like, should we even be trying to group up all the most important messages in a channel that we think are relevant for you if I can't sit down myself and scroll through this entire list of messages and pick out 1, 2, 3, and 4? If this is not something that we feel like ultimately we can, is a possible use case to support by literally what's in front of you and like what your situation is in your product, then you shouldn't try and like predict that. There's nothing else that's going to come from this that machine learning is going to get you. If I felt like I couldn't go through a channel and say, oh, okay, here are the 5 most relevant messages for me over the past week or so. If I couldn't do that, then forget it. Like, what am I really trying to predict? And then another way to echo the same things that have been said is if there's already some representation of the thing that you're trying to predict that exists. So one example, if you're document editing software and you're trying to predict whether something, one of the lines in the document is actionable or like an action item. Well, is there something that's part of your product that already allows people to like designate action items? Then that might be a better time to like start machine learning after you already have that, because you have a better idea of like what you're actually trying to do. Versus going at it blind and trying to have some other proxy for what something actionable might look like. So I'd say like when the manual or heuristic version of your machine learning model already exists in a product, that's a good time to do machine learning. And when you feel like you can kind of humanly come up with an analogy or humanly do the thing that you're expecting the machine to do, and it makes a lot of sense for serving the use case that you're trying to, okay, now let's start machine learning. It's probably a good idea.
Got it. Okay, next question. So we have a lot of people here who might be interested in actually, getting their hands wet with machine learning. What sort of backgrounds do you need as a PM in particular to be doing machine learning? And how is the job of a machine learning PM different from a regular PM?
In terms of the background, I've seen very successful product managers who are working on machine learning models and solutions coming from a variety of backgrounds. I don't think you actually have to have a CS or math background, as long as you're curious, you're willing to learn, right, and just overall kind of learning on the go and have access to the right talent who can teach you along the way. In terms of, and the other question was,
Yeah.
how is that different from?
Yeah, how is it different from other PMs at your company?
I think it depends on the type of machine learning you're doing. Whether it is kind of something at the core, kind of fundamental, you're writing, like you're working on an NLP solution, for instance, right, like that sort of thing, or you're just applying machine learning to your product. I think it varies. But if you're overall kind of, but in general, I think if you're a machine learning focused, data focused product manager, you definitely need to understand what it takes to train it, like the whole life cycle, right? Like getting data, training data, training the models, and then like overall kind of QA life cycle, human judgment, evaluation, experimentation, and so on and so forth. And just, really you need to understand that and have experience doing that. And other thing is you work with relevance engineers. You work with machine learning engineers, whereas if you don't use machine learning, you wouldn't interact with those folks.
Yeah, I'd say one thing that differentiates a PM who works on machine learning from someone who doesn't is that you kind of have a lot more of the see it to believe it mentality, and I think you work with a much more prototype driven team. A lot of that has to do with what we were talking about earlier around you don't know that this thing is going to work, and you certainly it is much harder to give an estimate. So while PMs who are working on much more deterministic things that they can kind of know this is going to work if we do this thing. We're going to give this offering, it's going to be interacted with in this way, and that's going to work, right? There's a very just kind of the specification of what you're doing is very deterministic in that way. So it might be easier to give your product marketing team a heads up of when that's going to launch, versus when my product marketing team comes to me and says, hey, when is the exact date that you're going to launch this thing that we're talking about? I cannot give them an answer, and I just basically make something up entirely. I think it's the best I can do. Yeah.
Yeah. So,
sorry.
No, go ahead.
What was the other thing? The other thing I think in working, you mentioned working with relevance engineers. You're also working with relevance designers in a way who have to think a lot about the virtuous cycle that you're trying to create of feedback that continues to feed your model and make it better over time. So you make some product choices that have more to do with the feedback that you can collect to improve your model than you do just strictly serving the use case. So sometimes you have to draw more balances. Like there may be something that 100,000% is going to be better for the user experience, but you're not going to actually get the information or feedback that you need. So maybe you make a small trade-off so that you can make sure that you're improving your models over time. So you're working with relevance engineers who give you the requirements for what they'll need to improve their models, and you're working with relevance designers who can lay things out in such a way that you can get this feedback to continue improving.
Question?
Thanks. The relevance designers, I think this is something that is so interesting because the work that Netflix had done around, and I think, I don't know if Pandora did this as well, but originally they had a star system. And then they moved to the thumbs up and thumbs down. And one of the things, and you guys probably know this, but for anybody who doesn't, just they just had decided that it was too much choice and it was mudding up the back. And when you mentioned for the channel, for the highlights, there's a thumbs up, there's a thumb down, and there's a dismiss. And so I would love to know, and I don't know if you're far enough along yet in what you're learning, but someone could hit dismiss because they're pissed, right? And that's hard to tease out. But do you have any thoughts on that?
Yep, that's exactly right. And beyond just the actions that we allow for feedback in highlights, there are also plenty of actions you can just do in Slack that mean very different things. So starring a message, setting a reminder on a message, pinning a message to a channel, right? So I feel like exactly what you're saying. How do we, either reduce, simplify, while also serving use cases to make it much more clear, to have a much clearer signal? And in terms of our feedback mechanisms, the feedback we use to make different decisions, right? So the thumbs up, thumbs down, we usually use to make thresholding decisions. So for example, when our model outputs a score, and we say that score has to be above, X threshold, we use the thumbs up, thumbs down feedback to kind of tune that threshold more than we do to feed it back in the model itself, right? So the model will continue to produce the same score that it does, but the thumbs up, thumbs down, we can look at, the inflection point of when we get more positive feedback versus negative feedback and where that threshold line is and go, okay, we can move this up and down. So each of these signals and each of these kind of buttons and dismiss, things like that we use for different reasons. And as long as and again, this is maybe what also differentiates machine learning PMs from people who don't work on machine learning, is that those are the sorts of decisions that you're making up front. And if we think dismiss is a no-op, it's a no-op. And that's something that we just offer for people because we know that's the experience they might want, right? So that's, again, the trade-off that you're making. Is a lot of people asked when we first launched this, we got to get these messages out of here, because we didn't have that at first because we knew it wouldn't necessarily help us, but they really needed it. So it was like, okay, we'll add that for you. So yeah, great question.
So my question is, for example, as a product manager, and what I'm trying to understand is when you start thinking of a problem, in machine learning, there's a feature set involved where you decide, okay, these are the features we'll be training the machine learning model on. So as a product manager, do you initially decide that these are the ones that we'll be training it? These are the ones that we should initially use to train the model? Or is it the engineering side which decides, based on the data, that these might be the potential ones? How do you come up with the feature set?
Always been really a collaboration between engineers, data scientists, even designers. I include everyone in the brainstorming discussions around what features should we be using. From there, what kind of criteria, characteristics do they think is important to arrive at the right solution, right, or right answer, sort of thing. So, and always engineers and data scientists found that to be very helpful. And of course, then they will do analysis on, hey, we can actually get a hold of this data, or we don't have this kind of data, or we cannot get this kind of data. But we brainstorm around how we can get that data also, whether it's working with other vendors, or right, going about it in creative ways, or maybe crowdsourcing and that sort of thing.
So do you also take into consideration what customers, is it the customer first, or is it the engineering first based on the data? What is more important, and how do you create that balance?
In terms of identifying what features to use?
How do you train the model? How you build the model, basically?
Yeah, I think it's just basically we throw all the features that we can, to the system. I'm not sure what you mean by is a customer first.
For example, say you try to create a personalized model.
Mm-hmm.
That personalized model is, do you define the highest priority should be job or the connections, or is it the engineering which sees the data set and decides that maybe the job could be the first one? How does it work?
No, yeah, that's a good question. So it's actually the model is trying to figure out the weights, right, for those features. So you just input, get all the input all the features, and it model is for us for search, for instance, based on search, what we think is successful search. We look at, okay, so these, it basically learns the weights for those features. So it is the model that figures that out. Yeah.
Hey, I'm Pranav. Hey guys, I'll just start. I'm Pranav from Salesforce. I'm engineering manager, and I just started managing our data science project. And for past couple of months, one of the big pain is, as some of you mentioned in your slides, getting started with data. And one of the big pain is how to label data, right? So how you solve that problem? Like you have a labelers in your house, or you use some auto labeling tool out there? How you are solving those problems? Because yeah, so that's the question. By the way, great
Feel like you can
presentation.
start?
Yeah, I can talk a little bit about that since that's a problem that we've been looking at recently. So there are a few different sources of labeled data. One is having the person who's working on the model actually generate the labeled data. And one thing that we found helpful for that was actually building a tool in-house that allows us to more quickly label data by one, having an interface that is simple to use, where you can just use keyboard shortcuts to do the labeling, and restricting it to a binary label to make the question easier for the person to answer. And the other thing that we found is that's pretty useful is adding an active learning component to it. So essentially what we do is we have a model that's trained in the background on the set of data that we'd like to label. And then we take the instances that we're the least certain about, and we try to label those first. So hopefully then we end up being more efficient through our labeling process and not labeling a bunch of instances that our model would already get correct. The other thing that we're doing right now is looking at external vendors for doing like more crowdsourced labeling. That's still in process, but that's another thing that we're looking towards. And the last one is just doing kind of the same as the first one, where the individual who's building the model is doing the labeling, but having the entire team do it. So just kind of getting more people to introduce the labels.
But I'd like to add one other thing to that. Is this on or not? The question somewhat ties also to, do you build your own data set or do you use someone else's? And startups love to go, like particularly with image stuff, they're like, I'll just like grab a bunch of stuff off Google, and it'll search for this and I'll grab those images and label it. But what you end up finding out is, which you brought up earlier, was the context of that image and how it was used and what that picture was is pretty important to like the specific use case. So, you can't just grab a generic picture of a kitchen out of a catalog and then have it work for your particular scenario. And the same is true with most categories. One of my favorite was listening to somebody who had like trained a system up on self-driving cars, but then went to a place in the world where you drive on the other side of the road and all the training was basically garbage at that point. And I thought that was fairly fascinating, but it's true across virtually every category is the context. Like you pretty much should just plan on building your own training data set. And for most of the startups I work with, they're labeling their own data. Or you can go with a mechanical Turk type of solution if you want. But the bigger challenge is you have to actually provide the images or you have to provide the data set for labeling. And it has to be in the context. And even little things like if ImageNet was trained on images that were certain pixels by certain pixels, then and yours are a different pixel by pixel, you might not be able to totally leverage some of this stuff. So there's a bunch of little things there too that you have to take into account that people don't realize. But just build your own data set. It turns out you can actually do quite a bit with your own data set and label it.
Yeah. To that point, one thing that we also noticed is for the test data set, it's really important to draw things from the distribution of whatever people see on the site. So for our image test data set, we actually drew essentially a uniform random sample of images, weighted somewhat by listing views, because that's a little bit more representative of what users see, and then went through and labeled that set. Because the method that we used for getting the training data, for example, was slightly different, and that was okay, where we could use the image captions to draw images of different classes. But for the test distribution, it's really important that it actually matches what users see.
And there's new tools coming out that eventually, like, you could take your image and just strip out the things that are unique about the image, the beds and so forth, and then label those, and then start even getting more sophisticated with the labeling process, which then solves even more and more of your problems.
Yeah, one question for Leonard. So you look at a lot of startups, and today I feel like every startup I talk to says they're doing machine learning. How do you assess those startups to figure out which ones are solid and which ones are really
Just saying they're
pretending.
AI?
Yeah.
Well, if you're smart, you say you're AI because it basically you'll automatically get an article written about you because everyone's clicking on the word AI right now. So they're all bright for saying they're doing AI for that reason. Going back to that slide where I showed sort of like listening, comprehension, looking, seeing, decision making, and actions. When I run into companies that are doing things with vision, my bar is a little bit lower in the sense of my concerns that they can solve the problem, because basically, whether you're looking at an image of a tumor or you're looking at an image of a dump truck, they're all pixels, and there's a standard sort of model and approach, and there's a ton of tools out there that you can do it with. I'm not saying it's like trivially easy after that, but you don't have to really worry whether the technology exists to identify what's in those images. You just have to debate whether the team can do something with that and build those images up and actually build a business around it. But you're not really wondering if it's possible to identify what's in the pictures, which means most of computer vision startups have a really good sort of head start on at least the confidence that they're going to be doing what they say they do. The other areas become much harder. So then I'm stuck where someone says, hey, I've got this new chat system that's going to really interpret your requests and respond to them. And I'm like, I've never seen it work, ever. And I've never heard of any breakthroughs. At that point, I have to go in and dig in and actually just say, I need to play with the product. I have to actually see it and use it. And most of the time, at that point, it's really clear it doesn't work. And the problem is you want to support entrepreneurs who you want to give them the benefit of the doubt that they could get there, but there's nothing documented and there's nothing they're usually showing that says they found the breakthrough. The way that like Feifei found, with ImageNet and then higher speed with CNNs, that was a true breakthrough that then you could just say, you could point to it and go, I'm using that. And people could just say, yeah, I believe you. Lots of people are.
Yeah, maybe a few more questions.
Okay, perfect. Thank you. So this is sort of more of an ethical question. Do you ever stay awake at night thinking that the work you're doing is going to contribute to the end of the world with Skynet and, things like that? Joking, actually. But question is more around the first slide that you had, Leonard, or the second slide around US Web versus Google. The examples that you listed were really great. I was sort of waiting to what is the example of the machine learning only, the product or service or business that can only be built with machine learning? Because it seems like all the examples given were about using machine learning intelligently to solve current problems, essentially the US Web problem.
Yeah, no, good point. And I should have had a more concrete slide on that. The slide where I showed like all that work that was out there, from construction to medicine to every services business out there, flipping hamburgers to cleaning bathrooms, all of those are all things that if we nail autonomy, we nail the ability for a machine to understand what we want it to do, we nail the ability for it to see and understand around its world around it, the ability to make decisions of what I should do in this situation, the ability to then take the action and move around and do that. That's when you see the true, just crazy change in the future. That's the future where you look back and go, how did you people live without this? You had to change your own toilet paper? Like, I don't even understand how that even works. And so I think that's really what you want to see. The thing is there's a whole bunch of pieces that have to come, that have to be built up for that. So you can't build the iPhone when you haven't even figured out how to wire something up yet with electricity, right? Like, so you have to build all of those components up. And so that's going to take a little bit of time, but it's probably going to go faster than we expect. But that's what I see. I see 90% of work, mostly boring work, being able to be done consistently by machines.
Last question.
So just building on this point that we've been talking about, like the revolutionizing AI as opposed to AI just enhancing a certain product. Just had a couple of quick questions around. Firstly, how do new entrepreneurs come up with business use cases that are viable to actually employ some of these things that are not now possible using AI? And then also, how do you as investors perhaps assess the sort of business viability of a particular idea?
So how do you come up with what's possible? Well, this is where maybe that same question of the product manager and the engineer and how do you have the balance between those two kind of plays in a little bit here, which is sometimes, so I like many of you, I have like hundreds of awesome ideas. They're genius, right? All of our ideas are super awesome. There are some things where you know very clearly how to make it happen. Like if you want to build an app for a phone and you want it to be something where someone fills out a form and then they submit it and something comes back, you can do that as a product manager and then work with the engineers, and you're not really questioning how that's going to work. But a lot of these ideas start with, hey, would it be possible if we could do, can we make a machine that could sew the sleeve onto the other part of the clothing? And then at that point, you better find the smartest engineers who've maybe worked on something similar or close. And they're the ones who you're betting on to basically take that idea and bring it to reality. And your job at that point shouldn't be to spec anything. Your job at that point to be get them whatever they need, right? Like you're running a biology lab for people who are going to try to discover the cure for cancer. It's like, what do you need? You want test tubes? You want this? You want that? I'll get you whatever you need. But it's really up to them. So I usually look for the engineers who've done something similar, even if it's not exactly the same. Think they have a pretty good grasp of how to do it, and also can point to a few other examples out there of things that are similar, like the image-related stuff, and so that you feel like they're not 5 years away. The last thing I'll say is I've come to appreciate in a way I never did before the investments we put into basic research in institutions and other things like that, because a lot of these things never, I used to think, does basic research matter? It seems like a huge waste of money. And now I realize, holy crap, we wouldn't have half the things that we have without that, because most of us wouldn't invest in those first 5 or 10 years of research. And now, if Feifei comes out with that, and now all of a sudden we have this tool that every business can now use to use it as a tool. So.
Well, join me in thanking our panelists.